So what we're going to do is we are going to use the three-dimensional Cartesian coordinate system to figure out the distance that stars are. I think that is really cool. And we need to use this crazy equation that you see right here. Now, what is this? This is all right. What is a Cartesian coordinates? Cartesian coordinates is totally just the same coordinates that you're always used to. It came from this guy called Rene Descartes, and it's the same coordinate with x coordinate and the y axis. The only difference is with the three-dimensional one, you have a z-axis, which points out of the board. It comes out of the thing. Cool? Now, do you need to know how to plot these things? Don't worry about it. Do you need to know how to do these things? Don't worry about it too much. You don't even necessarily need to know where it comes from. But I don't like pulling equations out of my butt and throwing it up on the board. So let me just kind of give you a heads up as to where it comes from. It totally comes from the distance formula. You know that d equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. All right. A, you've never seen it with the z, right? B, you've probably seen it with the x's and the y's. And, this might be a little bit scary. Here's where it comes from, just so that you know that I'm not lying to you when I say that this is the formula. You ever hear of this dude named Pythagoras? And Pythagoras, he came up with an equation, or a theorem, I suppose. What would you say his theorem is? Do you guys remember that? It goes something like a squared plus b squared equals c squared. Are we cool? And that's talking about how this part of here on the bottom is a, this part on the side is b, and the long part over there, that's called the hippopotamus, and that's called c. Or something like that, right? Actually, it's called the hypotenuse. Yeah. So in order to figure out that length c, the distance of c, can I solve for c? I would just square root both sides. Now, take a look at this. Doesn't these two kind of look the same? Instead of a C, you have a D. Instead of an A, you have this weird thing in the parentheses. Instead of a B, you have this weird thing in the parentheses. Yeah? Well, that's totally where it comes from. Now, what are you going to do for your homework? Am I going to ask you to prove the quadratic or the Pythagorean theorem every single time? No, don't worry about it. Here's what I'm going to have you do. Our first point that we want to choose, our x1, y1, and z1, is 0, 0, 0, because we're figuring out the distance from the sun. So here's what we're going to do. For x1, y1, and z1 in your equation, plug in 0, 0, 0, and 0. Cool, I love 0. 0 is fun. For x2, y2, and z2, we need to choose a different point. And so the different point we would choose is maybe this point, negative 3.4, negative 3.1, and 7.3. So all you do is this. Negative 3.4 for x2 minus 0 squared plus negative 3.1 minus 0 squared plus 7.3, and then square that sucker. Take the square root of that and you get your answer. And you just plug the number straight into there. All right, let me pause this.